This question gives us a function, g of x. It says find the first derivative. So that's easy enough, right? Um, so here, let me put it up here. So x cubed minus 6x squared minus 72x. G prime of x, just bring down the 3. Lower the power by 1, bring down the 2, lower the power by 1. This 1 power comes down, and then lower the power by 1, it's gone. So there we go. So there's the first derivative. And then it says, notice that g prime of x equals 0 when x is negative 2. So I guess if you plug in a negative 2 here, it'll come out 0. I don't know. You could try it, whatever. Now, we want to know whether there is a local minimum or a local maximum at x equals negative 2. So we will use the second derivative test. So first off, find the second derivative. So then we take another derivative. This 2 comes down. Lower the power by 1. This 1 comes down. Lower the power by 1. It's gone. The 72 is just 0. There's the second derivative, which they have right there. And so now they say, now take that and plug in negative 2. So if I put in a negative 2 right there for x, this will come out negative 40. Oh, and right there. Negative 48 plus 20. Wait. Gee, did I do that right? Um, minus 48 plus 24. I'm not getting what they're getting. Oh, there should be no x there. What am I doing? There's no x there. Right, because the x is gone. I said it but didn't do it. So minus 12. So yep, minus 60. There's the second derivative. Okay. So what does that mean? Based on the sign of this number, does this mean the graph is concave up or concave down? The answer is concave down. Why? Because second derivative tells you concavity. So in other words, we know when f double prime is negative, or g, I guess it's g double prime is negative 60, that means it's concave down. So second derivative is a test of concavity, meaning like a bowl. It's like a bowl turned down. It's concave down. So because it's negative. If it was positive, it'd be a bowl turned up. That's the second derivative is positive. So, okay, so it's a bowl turned up, so it's concave down. Now, based on that concavity at negative 2, does this mean that there is a local max or local min? That's pretty easy now, right? Because right here, is that a max or a min? Well, that's clearly a max, right? So whenever you're part of a bowl turned down and you're the point, remember that's where the derivative is 0. They said we didn't test it, but they said that's the point where the derivative is 0. So that's a max or a min. Which one is it? It's a max. Because whenever you're part of a bowl turned down, the middle is a max. If you're part of a bowl up, the middle will be a min. And so that's all they want us to see there.